All right, cool. Here we go. So last video. So at this point, we've talked about how to calculate the slope, either from a graph or from 2 points. So now we're going to look at it in context of a real life situation. Okay, so interpreting slope, not only should we be able to calculate it, but we also need to know what it means. So we're going to look at a couple of different examples and then see how we can use the slope or how we can interpret what the slope is. Okay, so the first one. So my daughter is starting to save what little money she gets, here and there. So the following shows the balance in my daughter's savings account. Okay. First of all, I want to know what the slope of the line is, and then what does the slope represent? Okay. So we know how to get the slope. So let's start by doing that. We know how to calculate the slope, so let's start by doing that. The first thing we need to do is we need to go ahead and make a triangle. Okay, so let's make our triangle. We're going from this point up to this point, which means that we need to go up. We need to go up, and I'm going to make this. Blue. There, just to distinguish it from everything else. All right, so, and then from here, we need to go to the right. Okay, so first we went up, and then we went to the right. So the question is, how far did we go up? And so we can't just count the squares because each square is not worth 1. So we have to count. Let's see, from 120 to 240, which means we went up 120. And so up 120. And it's important to know the direction because the direction is going to tell us whether it's a positive or a negative. And then here, we went to the right. We went to the right. So let's see, each square looks like it's worth 5. So 5, 10, 15, 20. So we went to the right. $20. So when we calculate the slope, remember the slope is the change in y over the change in x which is, so we went up 120, so that's positive 120 over, we went right 20, which is positive again. Okay, 120 divided by 20, that's going to give us a slope of 6 when we reduce it. So a slope of 6. Okay. Now the question is, what does the slope represent? Okay, and what the slope represents, remember, you got to go back to the definition. Okay, the slope, remember, is change in y over the change in x. So the slope, make this a little bit smaller. So it represents the change in her bank account. Remember, the change in her balance over time. And over time. Okay, so, and that time just happens to be in months. Okay, so the slope represents the change in her bank account balance over time. Okay, and you can even, if you wanted to get more specific, you could say that it's over a certain number of months. Okay, because that shows that it's the change in x as well. Okay, so the slope represents the change in her bank account over a certain number of months, because that number of months can change. Okay? So you're always going back to the definition when you want to interpret it, because it's the change in y over the change in x. And just you have to talk about what y is, you have to talk about what x is. All right, so let's do one more. Now, this graph represents a walk that my wife recently did. Okay, she went on a walk, and she measured the time and the distance, how far she had left to go. So what is the slope of the line? Okay, so we got to get the slope of this line. So let's figure out the slope of the line. We have to make our triangle again. So we make our triangle again. This time we're starting here and we have to go down. And then after we're done with that, we go from here and we have to go to the right. And now we got to figure out how far we went and whether we went up or down. So up here, it looks like we had to go down. So we went down. And we went down, let's see, because each one is worth 0.2 miles. So it looks like we went down 0.6 miles. So we went down 0.6 miles. And then we went to the right. And we went to the right 2 squares. Each square is worth 4 minutes. So right. Let's see, 4 minutes. So that would be 8 minutes. So right 8. So we went down 0.6 and right 8. Okay, you always have to take into consideration what each box represents. Okay. So our slope, which is again change in y over change in x. Now when we go down 0.6, that's going to be negative. So negative 0.6 over right, which is positive, 8. Okay, now, even though this is a ratio, and we're allowed to have decimals and fractions in ratios, whenever we write the slope, we want to write it with whole numbers. So we want to write it with whole numbers. So the easiest way to get a whole number here is to multiply each, the top and the bottom, by 5, because that's going to give us a whole number and get rid of the decimal. We need to get rid of the decimal. And the smallest number that we can multiply to get rid of the decimal would be 5. I mean, we could multiply by 10, but then we're going to have to divide by 2. So multiply by 5, we're going to end up with negative 3 over positive 40. The reason I did 5 is so that I didn't have to reduce. I could have done 10. That would give us 6 over 80, but then we'd have to reduce by 2 to end up with negative 3 over 40. So our slope is negative 3/40. Okay. And then back to what the slope represents. Now, please recall that the slope is always change in y over the change in x. So here, the slope represents the change in her, or maybe not her, the change in the distance remaining on her walk over given a certain number of minutes. Okay. And you could say that it could be the change in the number of minutes or an interval. Okay, there's a lot of ways that a lot of words that you can use to describe this. But as long as you get the essence of the change in y over the change in x, that's the important thing. You always want to make sure that you look at the change in y over the change in x. That's what the slope represents, and you just have to put it into words. Okay? Try to make it as thorough as possible. So the change in the distance remaining on her walk, given a certain number of minutes. Again, you can use a certain interval of minutes. Because it's always a piece of the domain. Always a piece of the domain. All right, so that's how you would interpret something like this. You got a couple of different examples there. Please make sure that you're doing all the practice. Okay, the stuff from the book is good this week when it comes to the homework. And so make sure you get it all done. Make sure you do the check for understanding. Have a wonderful, wonderful week, and I will see you in class.